Good morning, everyone. Thanks for joining us for our presentation, Designing Commercial PV Systems with AEE Solar, brought to you by AEE Solar. Thanks for joining us and taking a little time on your Friday. We know you're busy. While we wait for everyone to join in, I'm just going to make a couple of quick notes and announcements. Before we begin, if you are experiencing any technical difficulties, if you're not sure you're seeing the right screen or you can't hear me very well, you can type in any question or comment, and that'll be through your control panel on the right-hand side of your screen. There should be a little questions box there. You can just send it over to me and we'll get everyone sorted out before we begin. There will also be a brief survey that will pop up in a new window once you exit the webinar. It's just a couple of questions, I believe, maybe 4 or 5. We're just looking for your feedback on this presentation and any suggestions you have for future presentations. And if you complete that survey, that should only take you a couple of minutes. We'll send you a copy of these slides. So you'll see how valuable they are as we go through the presentation. It's really worth it. And also, we will have our Q&A session following the presentation. You're welcome to submit your questions at any point during the webinar, and we'll do our best to answer as many as possible after the presentation. And that'll be through that questions box on the right-hand side of your screen. All right, looks like folks are joining on. One last time for everyone new who joined on, if you have a question at any point during the webinar or any comments or you're having technical difficulties, you can send those over to me through the questions box on the right-hand side of your screen. All right, well, it looks like we don't have any questions, so I'll introduce our presenter today. We have Glenn Hall, AEE Solar's very own solar applications engineer. Glenn, I'm passing it over to you.
Okay, thank you, Hannah. I want to welcome everybody to today's presentation. We're going to talk about designing commercial PV systems today and the insights and the trends that we're seeing in the industry. My name is Glenn Hall. I'm one of the applications engineers working here that will help you design systems if you're developing projects through AEE Solar. And I've been at AEE for about 6 years, mostly working with grid-tied and commercial PV projects. So we're going to discuss some of the trends that we're seeing in this year in the PV industry. We've seen some major developments over the past years, especially last year. Most states have adopted or are in the process of adopting the latest NEC code, and has changed the way that we're deploying commercial rooftop systems. It's also very uncertain right now, very uncertain landscape with module supply. With the ITC tax credit sunsetting, with the tariff question coming in, with tariffs on materials, and it's being a little difficult there to keep up with that. So we're also seeing new product developments and releases in modules and also in inverters. So let's go with the presentation. I'll start with the agenda that we're going to be discussing. So in developing your projects and in looking at what modules to use, we're going to talk about considering using 60-cell modules versus 72-cell modules. We're going to look at trends and developments in sizing PV arrays in regards to inverter capacity. Also look at when you're developing your systems, what we should be considering for the tilt of the arrays with regard to spacing and trying to achieve power densities on our rooftops. We'll also be discussing NEC rapid shutdown concerns. Most states now, like we said, have adopted NEC 2017 requiring module level rapid shutdown. Other states have moved to NEC 2014. We'll be further discussing trends in inverter advances. Look at commercial roof racking systems, including ballasted systems and SnapNrack's new Ultra Rail system. Also be looking at commercial scale ground mount systems and looking at some solutions there for you to consider, including ballasted racking systems from Aero Compact, SnapNrack Series 200 systems for small and medium-sized commercial systems, and also the new PLP Power Peak pile-driven and cement-piered ground mount systems. If we get time, we're going to talk about commercial PV monitoring systems and some of the benefits that you guys could achieve in considering adding that to your offerings. And if we have time, we'll make a brief mention of being sure to include the ITC tax credit and also macros depreciation for your commercial scale projects when you offer those to your customers. So first of all, let's talk about considering using 72 cell modules versus 60 cell modules for commercial projects. So right now in the USA, module supplies are very uncertain. We had a very large spike in demand for 72 cell modules, and those modules are in very tight supply due to the drop in the ITC at the end of this year. So we are seeing projects that are locking down large quantities of modules early, and lots of safe harbor activity and modules being reserved for utility scale and large scale commercial projects ahead of time. So projects that have long lead times, if you need modules quicker, you may want to considering looking at 60 cell panel modules, which are generally in larger supply and more readily available. Oftentimes, they're not much higher cost per watt than the equivalent 72 cell modules. You just need a couple more of them since they're less wattage. There's 60 cells as opposed to 72. But the power densities, sometimes we see those power densities on the 60 cell modules. The companies, since those are residential modules, mostly companies are using they're better cells in those 60 cell modules, and then reserving the other cells for the 72 cells. We've seen more development in PERC technologies, as well as, one second. Okay, sorry. So we're seeing developments in split cell modules and PERC modules, which are increasing power densities in both 60 and 72 cell modules. Also be aware that in some areas, due to snow loads or high winds, your 72 cell panels may not be suitable for commercial applications. We do definitely have to consider those. For some applications, the 60 cell modules, since mostly they're black framed, there's more aesthetic options there. And we're seeing a general phase out of polycrystalline modules, very few offerings of polycrystalline modules in the US, transitioning to monocells, and then the monocells transitioning to cells to achieve higher wattage and efficiency, transitioning to the PERC and the split cells. Current product offerings that we have at at AEE Solar, we do have supplies of the Canadian Solars, both in the 305 watt standard monocrystalline. In the later, we were going to get the split cell version of that, which could achieve 320 to 325 watts in a 60 cell format. For comparison there, we have the Q cells, that is not currently available. We just exhausted our supply of REC 315s. That was the split cell monocrystalline panel. And then always we have the LG panels that are the premium offerings, which could achieve up to 360, 365 watts in a 60 cell format. For 72 cells, our offerings right now, currently we have in stock the Longi 72 cell 360 and 365 watt panels. And in the fall, we are going to potentially bring back and have a resupply of REC, the 370 to 375 watt monocrystalline split cell modules. Available for drop ship potentially, Mission Solars, possibly some of the very high efficiency LG 400s as well. So let us know your project needs and we will try to accommodate there. But I think the main message for modules this year is try to be flexible with your offerings as you're presenting that to your customers. Try not to get locked down in a particular module because module supplies are very uncertain right now. So with commercial PV design trends, with the inverters, in the past, most companies had agreed that most installers would try to achieve a pretty tight DC to AC ratio and not have a lot of extra PV concerned about power clipping and wasted power. In today's market, with the module prices dropping as much as they have been in the past, much quicker than inverters and balance of system costs and other soft costs, and also with the trying to achieve the most power per dollar for your customers, higher DC to AC ratios for inverters are becoming much more common. So 130, 135% of PV to your inverter ratios. And inverters are specifically advertising that they can achieve these higher ratios and be warranted for that and be consistent with the output. So SMA's Core 1, the Fronius Simo inverters, and SolarEdge inverters, they all can utilize pretty high DC to AC ratios, sometimes up to 150%. So definitely check your module cut sheets, your installation manuals. In the case of the Core 1 50 kW, for example, the 50 kW inverter, we could support up to a 75 kW DC solar array with just that single inverter. So, you know, on a large project with 200 kW or 300 kW on the roof, we could, by pushing that higher DC to AC ratio, remove 1 or 2 inverters from the mix. That definitely simplifies your installation costs. It lowers your labor costs, less inverters to warranty and service, set up for monitoring. And the benefit there is that your inverters reach peak output earlier in the day, and we see minimal clipping during higher radiance, and we generally allow that. And the inverters are not damaged by this higher PV array power. So anyway, that results in lower costs per generated kilowatt hour, and that's what your customers are really looking for. In addition, some installers still are insisting on higher tilt angles for rooftop commercial projects. Those higher tilt angles, they result in larger inter-row shading, spacing, to prevent shading of one row to the second row of modules. A high percentage of net meter solar production, that occurs during the summer months when the sun is high up in the skies. And we're only, that lower tilt angle allows larger PV arrays and a more dense solar array to be deployed. And overall, that gets you more net energy production for your customers. We also are offering east-west racking solutions, which completely eliminates inter-row shading and allows a very tight module density to be deployed. So the lower tilt racking and the east-west racking, what that does is, like we said, maximizes your module density and overall lowers your install costs and ballast weight. So with the lower tilt, we need a lot less ballasting to be on the roof. Less windscreens need to be deployed. With the east-west racking, no windscreens at all. So that definitely helps your labor and installation costs. Some are also considering facing arrays to the southwest or even to the west in high time of use area states and utility districts. The time of use rates are much higher in the afternoon, so there might be some consideration to face arrays either southwest or west, as opposed to direct, if there's a choice there. Calculators like helioscope and PV sifts could be used to calculate the amount of power that can be lost to clipping, and also calculate the value of facing arrays west or south. And then you can choose your inverter capacity and your tilt and orientation to maximize your value to your customer. Rapid shutdown considerations. So as we have been dealing with quite some time, rapid shutdown. So we all know the NEC 2014, most states are moving to 2017, but 2014 was string level rapid shutdown and applied to all conductors outside a 10-foot boundary for the array. So conductors outside that boundary, we need a string level rapid shutdown solution, and oftentimes for commercial applications, that was met by locating the inverters up and amongst the array to meet rapid shutdown. So roof-mounted commercial inverters within this array met that array, but however, they're not going to meet the updated NEC 2017 code, which requires module level rapid shutdown, or basically the array voltage within the PV array to be under 80 volts. So the freestanding or ballast mounted central inverters don't meet that anymore, and we need a different solution. So some examples of third-party string-level rapid shutdown solutions that met NEC 2014 were the Midnight Solar little shutdown box, the Birdhouse Midnight with shutdown boxes, and Innovative Solutions had offered a string-level solution as well. However, we have not seen too many people adopt those methods. So 2017 code, like we had mentioned, reduces the PV array boundary to 1 foot, and the maximum voltage within the PV array is now down to 80 volts. So the boundary shrunk, and we have the interior array voltage now being in effect. So that was adopted. There was a clause in there that prevented the implementation of that interior array voltage until January 1st, 2019. But now we are all under those constraints. So essentially that requires module level rapid shutdown. Some optimizers and some solutions have 2 modules plugged in series together into a single box. One has to be careful of cold estate conditions, VOC cold estate conditions. If those 2 modules in series exceed 80 volts, that solution is not applicable there. So those may be over voltage on the coldest day. So please be aware of that. There are solutions that will meet this with both optimizers and other MLPE devices. So here is the current map that we have for states that have adopted the different code levels. And as you can see, there's only 4 states out there and a couple ones without a universal statewide adoption. There's only 4 states that are on 2008 and 2011 code. 14 states are currently using NEC 2014 code, and now up to 29 states are using and have adopted NEC 2017 code. Next slide here shows that many of those states are in the process of adopting NEC 2017, including California. That'll be effective January 1st. Florida that's actually next year. Indiana, as of the 1st of the year. Maryland, and other states are in the process of updating their codes to NEC 2017 as well. So what solutions do we have to comply with NEC 2017? So module level options that we have. So the one that has had most interest is using the Tigo TS4-F MLPE shutdown device. So that is a box placed under each module. The advantage here is that it's using the new SunSpec compliant inverters. The SunSpec compliant inverters basically provide a heartbeat and a signal to these shutdown devices, and as long as that signal is present over the existing wiring, over the power line wiring, the DC plus and minus wiring, that device stays in the open position and allows the module to be connected to the system. If it loses that heartbeat, if it loses that signal, then it performs a shutdown. And then the inverter would handle the bleed down there. So SunSpec compliant rapid shutdown module inverters include the SMA residential inverters with the -41 designation, SMA Core 1 inverters with the -41 designation, Fronius certain SIMO inverters, if they have the advanced nomenclature behind them, they are SunSpec signaling. So be careful there that you don't choose one of the inverters that is not labeled advanced. So the advantage of the Tigo F is that we don't need any additional wiring, any gateways, and all the communication is over power line. Also available for use with just about any grid-tied inverter is the Tigo TS4-R-S or the -O MLPE devices. The S is for safety, and the O provides the safety features and also additionally optimization functions there. Just like the Tigo F, one would be deployed behind each module. However, this requires a separate communications box, so there are Cloud Connect and also separate gateways up on the roof to provide a signal to the MLPE Tigo S and O devices. So not only is it requires additional wiring and installation labor, but also it is a more expensive option than just the simple firefighter. That's what the F stands for in the Tigo TS4-F is fire. It's a more expensive option there. We were hopeful that we would see modules with maximum optimized junction boxes that would basically have that SunSpec receiving communications built into junction boxes and deployed to modules that are sold in the United States that would be compliant with SunSpec inverters, but we have not heard that this is an option. We haven't seen any development here, and it has not become available. Other options which one could potentially consider, the IMO Fire Raptor. That was initially, so we have 2 module inputs. You could do up to 2 modules to that device. That does have some of the same downsides that we talked about. We have to worry about cold state conditions. It is a more expensive device as well, and also requires a separate emergency shutdown switch and control wiring to each of the shutdown devices. Midnight Solar has been working on their little shutoff box. That was a very cost-effective solution for NEC 2014 for string level. For module level, you would need one little shutdown box receiver under each module. We have heard they're working on reducing the cost of that. We haven't heard too much more. Maybe we'll see something at InterSolar this year that would advance that product. Other ways of meeting that is go with a solution that brings the power electronics up there and is integrated with the system. So SolarEdge, their inverters and their optimizers, all of the single panel optimizers in the residential line could be used for commercial. So your P320, P370, P400, P505, you have to make sure that the optimizer works with the module you're considering using with wattage and voltage and current. And then the commercial optimizers that have 2 inputs, most notably currently is the P860 that has 2 inputs. So since each module is separately plugged in, the voltage stays under that. So the the single input commercial optimizers like the P730, where you do connect 2 modules in series, you got to be careful about that string level of string of 2 being over voltage, so it might not be applicable, and you have to move to the P860 for commercial optimizers. That optimizer we will be stocking at AEE. We do have shipments coming in, so if you have a commercial project you'd like to consider SolarEdge, we probably would have stock to be able to supply that, but please get your orders in and talk to us early. They're going to be in high demand, I think, at the end of this year. For smaller commercial projects that want to meet RapidShutdown without having to go through adding an MLPE device, you can always consider also using N-phase IQ and microinverters for 3-phase 208 or 3-phase 240, any of those style, or if you have single-phase systems. So we're going to see traditional string inverters. They might be limited to being used only on carports or for ground mount PV arrays. NEC 2014 and 2017 RapidShutdown, that is not in effect, and for ground mount arrays, it's only really interpreted and applicable for roof mount solar arrays. So let's talk about some of the advances that we're seeing in inverters. So a star performer that we've had for the past year now is the SMA new Core 1 inverters. They launched with a 50 kW version of that, and that was a -40 version that was not SunSpec compliant this year. They introduced a 33 and a 62 kW to complement the 50, and they moved that to the -41 inverter, so that's now SunSpec compliant and can utilize the Tigo F MLPE devices. There have been some delay in shipping the SMA and MLPE device to the Tigo Fs, but I believe they're going to get that worked out for the third and fourth quarters for this year. For the SMA Core 1 inverters, these inverters are really handy, very self-contained units. They ship on a pallet. They have 6 MPPT circuits, and they will allow up to 2 strings to each of those MPPT circuits. So you could bring up to 12 1,000 volt strings into each inverter. These do ship with Amphenol inputs on the input connectors. So you do have to make your own home run wires, but inside the packaging, they do supply the H4 connectors that you can attach your home run wiring for inputting into the inverters. Make sure you have the right crimper for that too. We didn't mention, but they're SA compliant, so they're applicable for installing in California and Hawaii. What's nice about them is they have an integrated AC and DC disconnect, so if there's ever an issue servicing the inverter, the top portion can be removed and quickly serviced. And we mentioned earlier, they have a very high DC to AC ratio that you can load these inverters up to. So especially if you have an east-west racking system, for example, we can push them right up to 150% and have 75 kWs to each 50 kW inverter, so less inverters needed for each installation. They have a new SMA Data Manager M communications gateway that replaces the cluster controller, if you guys remember the cluster controller. And multiple inverters can be linked to that. It's a Wi-Fi access point in the inverters with integrated data logger. Up to 4 do not need the SMA Data Manager. You can link them to the Sunny portal easily. And they're suitable for rooftop, carport, ground mount applications, especially for rooftop once the Tigo Fs are available in large supply. SolarEdge has also updated its commercial line. It's moving to a SETAP format inverter. They have both 3-phase 480 volt and 3-phase 208 volt inverters, 9 and 14 kWs in the 208 versions, 33 kWs as a standalone inverters, and also they have new large format inverters that they introduced last year. So basically the 43 kW 208 volt inverter is a core 14 inverter with an expanded DC disconnect, and then 2 secondary units that are on each side of it. So the second picture there shows you what that inverter would look like. In the 480 volt version, we have the 66 and the 100 kW. The 66 would be 1 core unit of 33 kWs with the extended DC disconnect, with 1 of the secondary units on the side, and the 100 kW unit is 1 core unit with 2 secondary units. These are of course SA compliant, so they've been installed in CA, California and Hawaii. Module level rapid shutdown, we mentioned we can use single optimizers, we can use the P860 dual optimizer. For areas that are still under NEC 2014, or for ground mounts, the single input commercial optimizers that can accommodate 2 panels, like the P730, the P850, for your higher wattage modules, they can still be used for those applications. Module level rapid shutdown is enabled. Inverters can be located down near the utility point of connection, and you can take advantage of very long DC wire runs. Your ease of installation for combining multiple inverters and connecting your monitoring can be easily achieved with these inverters if they're at the ground level. We mentioned N-phase IQ microinverters that are a possibility for 3-phase 208 applications and 3-phase 240 for smaller projects or for projects that are broken up that need to meet rapid shutdown. This is their 7th generation microinverter. We also can get the IQ7X if you happen to be using SunPower or Panasonic modules, those high voltage, low current 96 cell modules. 25-year warranty, and Enphase has an Envoy IQ for both single-phase applications and a new Envoy that will accommodate three-phase applications. We're highly hoping that they'll be on schedule to release their new IQ8, which will have advanced functionalities, hopefully at the end of this year or early 2020. So for commercial applications, again, we can put fairly high-level wattage modules to these. They're SA compliant. We have built-in rapid shutdown. And these really should be considered for your smaller projects or for carports and for constrained roofs that have broken up arrays. Some discussion on commercial rooftop racking. We've really seen a lot of development and a lot of interest in ballasted racking for flat roofs. We have the ability and the tools to quickly evaluate a roof surface with a simple one-page intake form. So for us, it's pretty quick and easy to design these systems. We're seeing that fewer materials are needed for ballasted systems. And most importantly to some roof owners, with your TPO roofs, it minimizes or eliminates the needs for roof penetration. So you don't have to seal them, easier servicing the roof if there's ever an issue, and we see overall less warranty issues of the life of the PV array. Some considerations when you're considering a ballasted system though, in states like California that have seismic concerns, they may mandate penetrations for seismic anchors. These are generally at the corners of the PV arrays to keep the array from moving around. So most of the array is supported by ballasting, but seismic anchors may not be avoided in certain areas. For slopes greater than 5 degrees, we start to see, we have gotten some approval for over 5 degrees, between 5 and 10 degrees, but we do see the ballasting or need for penetrations in doing those. But the sliding forces tend to start to get too high on roof slopes that are greater than 5 degrees. Ballasting typically is not suitable for roofs over 50 foot high. Generally that becomes the tallest object in the area. The wind loads go up quite high as we increase building heights. And we have gotten some engineering review, but sometimes that requires wet stamps and third-party reviews when we start going above 50 foot high and try to force a ballasted system there. Penetrating systems tend to be better at those higher building elevations. So your wind exposure will drive your ballasting calculations, and be sure that the designer and supplier uses the correct wind loads, exposure categories, and risk factors. We do see some online tools for other ballasted systems that don't get a engineering review. All of our designs are reviewed by Aero Compact prior to being recommended to you as the customer. But we're getting feedback sometimes that, hey, you know, why is this ballasted system so much more than the other ones? And you know, I go on this online tool and it says they're not, because you're not potentially using the correct wind and exposure categories, or don't have the right building heights in there. So please be sure if you're using an online tool to estimate that you do get the right jurisdiction required wind and snow loads. So advantages of penetrating racking. So roof penetrations into the roof structure that anchors the PV array, whereas with ballasted racking, the weight of the array itself, the modules, plus additional ballasting and any anchors keeps the array in place. For penetrating racking, roof penetrations, we have to make sure that those are certified and sealed for the entire array life. With ballasted racking, we tend to avoid that by having few or no roof penetration. Penetrating racking is applicable for higher tilt angles. So if you do have a small array on a large building and you do want to tilt 20, 30 degrees, penetrating racking would be your solution there. We tend to keep the tilt angles low, typically less than 10 degrees for ballasted racking, to maximize the PV density and also to limit the wind effect. Penetrating racking we can install on pitched roof surfaces, whereas higher slope roofs, that eliminates the possibility of using a ballasted racking solution. The lower weight array on a ballasted system, we can get a lower roof dead load with a penetrating racking system if that's a concern for older buildings or a concern for residential building that has a high risk factor. You will see a higher roof loading with ballasted racking, especially if you're trying for a 15 or a 10 degree tilt there. Roof maintenance for penetrating racking often requires the entire racking and the array to be removed prior to servicing the roof. Ballasted racking, we can just remove a small portion of the array and just service the roof if it's needed right at the point where the roof needs to be serviced. Penetrating racking, because of the use of rails and the use of other wire management there, often wire management and MLP attaching is easier with that. We have to have special considerations if we're using ballasted racking for our wire management to keep the wires off the roof. And the MLPEs, any optimizers, microinverters, or shutdown devices have to be attached using frame mount solar attachment kits. So normally attaching a ballasted system, what we could do with the ballasted system, if we do have roof load concerns or seismic concerns, we can have a hybrid system. So most of the array is installed quickly using the ballasted system. We put select anchors in key points, or for any isolated modules, or for seismic. So overall, we only have a couple penetrations to flash and install. Most of the array is still removable for servicing the roof. And it allows an overall lower ballasting requirements than a fully ballasted array. So if we locate these penetrations correctly, they prevent the sliding of the array, and we can use the higher friction values of static friction, which further reduces our ballasting requirements. So there's a trade-off there. So less penetrations require more ballasting, vice versa. So if you tell us the dead load that the roof can support, and we can basically add some penetrations to any ballasted system and bring the roof load down to exactly what you need to satisfy your building owner or your jurisdiction or your plan checker. So sometimes a combination of penetrations and ballasting is the best way to meet the requirements at the site. Here is an example of the ballasted racking that we offer, and our most is the best seller so far at AEE Solar. So AeroCompact has been really great working with us. They have stock in the US and ship fairly quickly. They have a south-facing 5, 10, and 15 degree tilt array, an east-facing 10 degree tilt, an east-west 10 degree tilt, and that 10 degree east-west really maximizes the module density, and it generally really lowers the ballasting requirements. 25-year warranty on the materials, it's wind tunnel tested and UL 2703 grounding and fire code compliant. The AeroTool design software, we can get a full layout and ballasting plan typically within 24 hours. Sometimes if you need it, we can get it the same day. And AeroCompact does support all 50 states for wet stamp engineering for an additional charge, and we basically ask you to talk directly with them for that so that they can service you quickly if that's needed. Final engineering with a detailed bill of materials. So the engineering reports that are generated, the normal ones without the wet stamp, those are mostly accepted by the jurisdictions without having to go through the wet stamps. They're very detailed. There's a standard report and a very detailed report. If they want to see every calculation of every penetration, we can show that if needed. So there's pre-attached rubber pads on the supports. There's separate pads that you place under the ballasting trays where needed. There's a single tool that's used to assemble the racking. and we have support for penetrations. Again, like we mentioned, we can lower the ballasting or we can add them for seismic requirements. We have frame mount attachments to attach microinverters and shutdown devices, and we've seen over 300 megawatts of installed projects over the past 3 years with this product. Very popular. We're doing very well here. Here's an example of some anchor points. So on the right is a traditional post assembly with a standoff plate with the hardware that is supplied by AeroCompact to attach to that, and that one is flashed with a cone flashing. So a roofer would come after that and make sure that the TPO or the butyl rubber or the asphalt asphalt roof material is properly put up to that cone flashing. That's one way to do that. Another way is if you have a membrane roof, we have anchor points that we can recommend. We don't supply them, but OMG and Anchor Products are two companies that supply those circular anchor points for TPO and EPDM roofs. And that's how you would attach that seismic or additional anchor point with that situation. So here's a brief example I'll talk about, just to exemplify the point of using a lower tilt to get more production and more value out of your array for your customer. So I did a study in Sacramento on this roof surface and saw what I could place in it with a 15-degree south tilt racking, a 5-degree south tilt racking, and the east-west 10-degree racking, leaving walkways for fire department, leaving offsets from the roof. So the area is all the same. As you can see with the 15-degree south roof, I fit 1,245 modules for 373 kW. And for the 5-degree south racking, we got almost 200 more modules there, and then a further 150 modules approximately with the 10-degree east-west. So yes, your modules, each individual module is producing slightly less, and you can do that study in Helioscope or PV Watts or Folsom Labs or any other study there. But we're maximizing the module density. And the important thing is that megawatt hours in the production that we can produce there, we got a 15% increase in that building's area, the area of that roof module with the power and the modules we can put. We got a 15% increase in power produced with the 5-degree racking. I'm sorry, 9% increase in the kilowatt hours produced, and an 18% kilowatt hours increase with the east-west. That's all with the same roof type. Now, furthermore, so the ballasting up on the roof there, that 15-degree south racking though had a 3.22 PSF dead load with that specific site conditions, and we needed 3,270 ballast blocks to secure that racking. With the 5-degree south, we needed almost 1,000 less ballast blocks. We brought the dead load down to 2.8 PSF. So the wind is less subjected to the wind there, less subjected to the forces. With the east-west ballasting, we brought that down to a 2.35 PSF roof dead load. Lower cost for the racking since there's no wind screens, less ballast blocks needed up there, and that system only needed 910 ballast blocks to secure that array. So more power produced, lower cost, easier, quicker installs. Definitely would like to consider either the 5 or the 10-degree, 5-degree south racking or the 10-degree east-west for some of your commercial projects that really need to be competitive, be at a lower cost, and to produce more power overall for your customers. So moving on to other rail options, so Snap and Rack Ultra Rail. Snap and Rack has gone through a product update. Series 100 rail that's been the mainstay of the Snap and Rack line that is phasing out completely this year. We're down to pretty much our last little bits of orders. So we've developed a new lightweight rail called our Ultra Rail to be used in these systems. So if it's a pitched roof or if it's a penetrating roof system, we have a UR40 rail that's optimized for states with light to moderate snow loads, and it has a very large span capacity compared to other light rail products on the market. And there's a slightly stiffer version of that called UR60, which is our heavy duty rail and allows for longer rail spans and higher wind and snow loads, and be able to be deployed there. Still maintains the open channel for use of the wire management, and Snap & Rack has a full range of wire management options to help you with your installs. Single tool installation as well, so only one tool used to tighten all the bolts and connectors on there. We have a smart clip, a new smart clip for wire management, a new MLPE attachment for frame attachments, and it's compatible with all existing module clamps in the Snap & Rack line. So all the Series 100 end and mid clamps that were used still are the same for Ultra Rail. So if you have experience installing Snap & Rack Series 100, you should not have any problem transitioning to Ultra Rail. Moving on a little bit here, moving on to ground mount arrays. So commercial ground mount arrays, we still see small and medium sized systems being installed with conventional ground mount racking systems, and we can effectively compete with other products up to about 150, 200 kW. Just very quickly go out there and deploy it with cement piers with our Snap & Rack Series 200 racking. For example, 30 kW racks, so we can get 100 of 300 watt 60 cell modules, and that fits very nicely out there. In most environmental conditions, we can get that rack deployed on 10 piers in the front and 10 in the back. We have a small Bobcat operate that and dig the piers with cement, set the posts, and quick install. The downsides to using a pile-driven system on these smaller arrays is that special engineering studies, you have to usually do pull tests, or you have to be very conservative in your piles. That specialized equipment can add a lot of cost to your project. So up to about 200 kW, we've seen up to 300 kW where someone was bidding and wanted to get in there without having the delay, especially if you're trying to meet the ITC tax credit drop as of the end of this year. We talked about Series 200 UL, which is our ground racking solution, small and medium-sized commercial arrays. The 4-high module landscape orientation optimizes your cost and benefit there. It's UL 2703 listed, so we need one grounding point. The mid and end clamps will ground the modules to the racking. We have an online configuration tool that will help you determine the bill of materials and system and engineering requirements. And again, we have that one tool for all the mid and end clamps and the pipe fittings. So locally sourced Schedule 40 1.5-inch galvanized steel pipe. We installers source that at the site, and then that way it lowers the cost for those projects and doesn't add to shipping costs. We've seen a lot of residential installers take on their first or second large, medium or small commercial projects, and since they've done ground mounts in the past, they easily can offer this as a solution for those customers without having to learn a new racking system. We have PLP though for your larger commercial or utility scale ground mount systems. We can accommodate uneven terrain with this. This usually deploys in a 2-high portrait system, and it's to maximize the number of panels per support post. These posts are typically pile driven, but you can do them in cement piers for smaller installations or ones where you can't wait for that soil study. It is integrated grounding as well, the UL 2703. It lowers installation time and it ships as a component there. Ballasted ground mounts, seeing a lot of interest in this. So if we want to avoid all of the need for digging supports or soil studies, we have the ballasted system here, especially for in the lower 48 states. AeroCompact has a 15 and a 20 degree, 25 degree with special ordering, or the 10 degree east-west configuration. It has the longer legs, gets a little bit higher off the ground, but this is, we're doing quite a few of these, especially Arizona, Southern California, Texas. Quite a few of these we are offering for both residential and commercial arrays. So up to a megawatt of this racking can be shipped to a job site in a single truck roll. You don't have to buy the pipe. You don't have to ship large piers, and it installs very quickly. There is an option for either spreading gravel on the ground or mesh, fleece, control mesh for vegetation. Sorry about that. To control the vegetation on the ground. Here's a couple pictures of AeroCompact ballasted ground mount solutions. And again, this is very popular here. We have some considerations for the inverters that on ground mounts. So inverters for ground mounts, some do place them behind the panels on the racking to save space and simplify installation. Most of these inverters are NEMA 4 rated enclosures, so you can outdoor mount them underneath or behind the array. Example would be the Fronius Simos, or if you put a small pad, an SMA core inverter could be placed amongst the array there. And these would be decentralized inverters at the panels, and it really simplifies the array wiring. These inverters, however, do allow for typically 1,000-volt DC wiring. And instead, if we locate the inverters close to the point of interconnection, that would allow you typically smaller wire runs from the arrays back to the inverters. So you have more voltage drop with your 480-volt three-phase wiring than with your 1,000-volt DC wiring. You're mounting the inverters on your array would avoid extra DC disconnects potentially. But monitoring would be easier if the inverters are centralized in one bank. Running out of time a little bit here, but commercial system monitoring. We do offer inverter monitoring through a variety of sources. Inverter direct monitoring from SMA or from Fronius or from SolarEdge, for example. Enphase has their own monitoring system. Most inverters have a monitoring platform that can generally be ordered for free access as long as you connect to the internet. But values of commercial monitoring, we can identify problems quickly. Some commercial PPA agreements would require monitoring. And also we provide customer assurances of our plant performance. One trick here as well is a lot of these offerings allow a kiosk view. So if your commercial customer wants a view of that they can display, more and more systems are offering an easy way to set up a kiosk view. Other options for monitoring, SolarLog is revamping their platform and offering a new solution coming up this year. Their monitoring would talk to most inverter systems that are supported by them. There's a list of that on their website, but all the major inverter brands can do inverter direct talking and communication to SolarLog and pull that inverter level data in. One thing to point out is in some feed-in tariff situations, SolarLog can throttle back and regulate the output of the inverter. So in the second display there, you can see that they limited the output of that inverter to match what the consumption is, if that's a concern. There's options for cellular, there's options for revenue grade metering, facility consumption monitoring, as you're seeing here. If needed, weather station data and kiosk versions. We've been pretty successful offering eGauge. This would be a data logger with CTs placed around the output of the inverters. It's very customizable to your needs. Consumption monitoring can be included, as you can see in that display to the right. Real-time data monitoring, you can zoom into each inverter if needed, see the plant level, and basically look for real-time data and analysis there. options for eGauge as well as Solar Log would be to place the data loggers in NEMA 4 enclosures and offer cellular, Wi-Fi, or power line communications. That could help there. Briefly, I'm just going to mention that we do have our ITC tax credit sunsetting. So we have a 30% tax credit through 2019. In 2020, it drops to 26%, and in 2021, down to 22%. And for residentials, it would sunset, and for commercial, it's going to drop to 10%. This should be a big portion of your recommendations when you're offering a solution to a commercial entity. But also consider that you also the owner is also allowed to depreciate that solar asset using a modified accelerated cost recovery system, or MACRS, and you are allowed a 5-year accelerated depreciation for solar assets. This could represent a substantial amount of additional tax savings that they can take off the price of their system over that 5 years. So definitely see your end customer and review these options, and definitely review that with their accountant or tax attorney to see if what they can benefit there and help finance or pay for the system. I'm not going to go through the example. We're running low on time. Hannah, I think I'm going to conclude